2018 B3, the dihedral angle question. So again, a lot of people did really well on parts A, B and C, but again part D was a little bit trickier than the other few. So just for this, I'm going to go through this whole question start to finish. So a lot of people are really good at setting it up. So in, up and down is how you use all the measurements. So just for point E there, you measure in 100, pick a point start, measure in 100, you go up 45 and down 60. You're getting all of these points from the question itself. So you'll set up pretty much everything bar the points F, because that's for part C of the question. So you'll set up ABC and ABDE. Once you've that done, you're going to get the dihedral angle between ABC and ABDE. What's common between them is the line of intersection, which is AB. What I did was I did an XY line, so as my X1, Y1, and I brought out AB, and I took the heights of my elevation and I struck them off. I did the same with point C, because I need a point from surface ABC and I need a point from surface ABDE. I took E and C as my extra 2 points. So I brought out E, I took its height and I struck it off. I brought out C and I struck it off. And once I found AB, you look along AB and you measure from your last XY line back. Taking the distance to AB, you strike it off from your XY line, so you'll get its coordinate or point. Same with C, take the distance to C and on your line C, strike it off. Same with E, take your distance to E, again strike it off. And when you join all three together, making sure AB is in the centre, you're getting a dihedral angle of 80 degrees. And make sure again you're doing those two little triangles and dot to signify dihedral angle. Part C was long in the sense there was two things that were asked. So you've determined the point G in plan and elevation, so that was easy enough, you were given the heights of it. So once you have that, you can do the surfaces belonging to G as well. So that was fine. After that, you're asked to get the distance between points G and B. There's a few different ways of doing this, but you know, auxiliaries is always the best way because it's consistent and it works every time. So in plan, I joined G to B. I came out perpendicular. I used the GB as my XY line, took the height of B and struck it off, took the height of G and struck it off, and joined them together, and that's my true length. So that was fine, that's the distance between them. After that, you were told that to find the point F, you were told AE and GF are parallel. So if lines are parallel, they're parallel in every view. So with AE, I slid my set square parallel from G and I got F in plan. Same in elevation, found AE in plan or in elevation, came parallel, and I found F in elevation as well. And that is part C of the question done. So I've labelled this part C, and I've also labelled it down here, part C, getting your point F. The last part is the trickiest part. You're asked to determine a horizontal line drawn from C that will touch the plane AEFG at a point that's 55 millimeters from C. Now this is a lot to take in. So a horizontal line will only appear horizontal in elevation. As you would have understood before, a horizontal line in plan isn't necessarily horizontal. So in elevation, I'm going to draw a horizontal line at C. Just a long one. So I can see it's going through F because F and C are the same height. But it's found another point for me on the line AG, and this will help me find it down in plan. So I know it has to join to F, it goes through C, and this is another point on it, and I'm going to call it Q. Doesn't really matter what you call it. So find Q down in plan, it's on the line AG. And Q is a horizontal line that is joined through to F. Okay, so that red line in elevation and plan are the same, but I need a point that's 55 millimeters away from C. So measure 55 millimeters. And the line that has to go from C that has to be horizontal has to go through that point. So that is the line in elevation, yes, but it has to stop at exactly that point. It's 55 millimeters away. So this is actually the line we're looking for. And when you bring that back up into elevation, the line we're looking for from C, that's horizontal, goes just from here to here. Okay, sorry, that's not a very horizontal line because I didn't use my T-square, apologies. Just come horizontal from C until it terminates at that point, no further. Okay, so what I've done is I've created the horizontal line that's infinite in length in elevation. I replicated a similar horizontal line in plan, but because the horizontal line has to come from C and it has to be 55 millimeters long, this is one point that's in common, so that is the line. You are then asked to determine and indicate in degrees the true angle of this to the horizontal line and vertical plane. So essentially, this is where it's going to be its true angle to, so it has to be true angle to the XY line. So if I continue it on, I will get the true angle of that line because I'm looking down directly at it. So it has to be a true inclination. And the angle for me is 53 degrees. Okay, so that's the true angle of inclination, and that actually finishes off the question as well.